Alright, the covariance between two random variables x and y is the expected value of the spread of x to its mean times the spread of y to its mean. So basically the covariance gives you information how two random variables are related and influence each other. The covariance of the random variable n itself is the variance. That's quite obvious. If this is x minus e of x transpose, we have the formula of the variance. And the covariance is symmetric. So that's also important to know. So let us now look at a feature vector x of dimension d, with a finite mean and a finite variance, and we redo the experiment n time. We have n samples, so you have n column vectors, samples. So it's a d times n matrix. So let's take a look how this looks like. So x transpose x equals, you have here x transpose would be a row vector, so x1 to xd, and times x would be here x1 to xd. Okay. Now if we're gonna calculate this, this is a product, then basically the vector that we're gonna get is x1 x1, x1 x2, x2 x1, and you're gonna be all the way down to xd xd. This is the type of matrix you will get. Now let's take the expected value of this. So what we're gonna do is we're gonna take the expected value of x transpose x, and before we do that, we're gonna do mean normalization. That means that the mean is 0. Alright, so in a normal case, if you would have x1, x1, this would be x1 minus the mean times x1 minus the mean, and then the expected value. This we make transpose, and this would be your, if mu is 0, you have x1, x1 transpose, expected value, so that would become the variance of x1. So our matrix becomes the variance of x1 all the way down to the variance of xd, d dimensions, right? And on the other points on the non-diagonal, you're gonna get the covariance of x1 and x2. And here you have covariance of x2, x1. And you can build up that matrix in such a way. So now what we're gonna do is we're gonna multiply this matrix by n, by 1 over n, sorry. Okay, so we will then define the covariance matrix sigma as x transpose x divided by n. So this is your covariance matrix. Okay, so this matrix is what we call positive semi-definite. So this matrix is positive semi-definite. Alright, so this summarizes the covariance matrix capital sigma is a symmetric matrix. Yeah, you see these covariances are the same.